Hello, friends. Welcome to the ATC Double Cut. My name is Michael Woods. In this episode, I'm going to talk a little bit about summer and about the temperatures that happen in summer and a way that I like to look at how intense the summer weather conditions have been, especially for people growing cool season grass, or people growing cool season grass in the transition zone. And I'm so interested in how stressful the summer was, how difficult that year was, because sometimes we have record high temperatures or record stretches of hot weather day after day after day. And I think it's interesting to look at ways to assess how the grass may experience that. This is a blog post with the title Summer Assessment with Delta GP. And I want to explain to you what Delta GP is. By delta, I mean change. So it's the Greek letter delta, or a triangle for the capital delta. Delta GP. GP here stands for growth potential. And what it is the difference between the cool season growth potential and the warm season growth potential. And at first, it might sound complicated to use something with a Greek letter symbol and to say delta and to say we're taking two derivatives of temperature, which are the cool season growth potential and the warm season growth potential. We're taking those and then subtracting them. What's this all about? Well, it's I probably say this too often. It's quite simple, really. It's simple once you understand it. And what it is the cool season growth potential is on a scale of 0 to 1 or 0 to 100%. So if you have a high cool season growth potential, that means the weather's pretty good for cool season grass. The temperature aspect of the weather is pretty good for cool season grass. For the warm season growth potential, it's on the same scale from 0 to 100%. So if that is a high number, then we are going to have a relatively good temperature conditions for warm season grass growth. And that's what those are. And then by expressing the difference between them, or the delta, we can say which one is better. So it turns out that when you take the cool season growth potential and subtract the warm season growth potential, if that turns out to be a negative number, what that means is that was a day that was obviously better temperature conditions for cool season. That was better temperature conditions for warm season grass than it was for cool season grass. If that's a negative number, then that means that your cool season GP was high, something like 100, and your warm season GP might be low, something like 20. So we're going to have a positive value of 80. That means it's a much better day for cool season grass in terms of temperature than it was for warm season grass. However, when you have a really hot day, let's say the average temperature is 31 degrees Celsius, that's an average temperature of about 88 degrees Fahrenheit. That's going to be a growth potential of 100% for warm season grass. It's going to be a growth potential of about 20% for cool season grass, because it's much too hot for cool season grass to photosynthesize efficiently. And when you take then 20 minus 100, you get a value of negative 80. And that means that's below zero. That is clearly a day that is classified as much better in terms of temperature for warm season grass than it was for cool season grass. I want to, in this episode, I'm not going to make it too long. I'm going to explain 3 different ways that I like to look at summer, and you can think of how you might look at the summer duration at your location, and maybe if you have any better ways to look at summer or ways that you prefer, I would be really happy to hear about them. And I'm going to discuss the blog post Summer Assessment with Delta GP and show a couple of charts in this. I put links right at the start of this post, which there will be a direct link to in the show notes. I have put notes or links to two blog posts. One is checking the length of summer. I did this, I think, for the summer of 2022, and I did this post in the spring of 2023. There's a link to that in the first bullet point list in this blog post. And I've also done an analysis identifying a method for finding the optimum overseeding dates, when you might use perennial ryegrass or Poa trivialis, or maybe some festuca species, or maybe even a little bit of agrostis to overseed a warm season turf stand. I've used the Delta GP for identifying the length of summer, and I've used Delta GP for finding these optimum overseeding dates. I put direct links to those. And then in this post, I really wanted a chance to share a chart that has just been posted at Pace Turf. I said, an analysis at Pace Turf of summer temperatures in 2024 has the Delta GP expressed as a percentage of the 113-day period combining meteorological and astronomical summer. I'm going to explain what I mean by meteorological and astronomical summer a little bit later. For now, I want to have a look at this chart. For those of you who are watching this, you will see the chart. If you're not watching it, it might be interesting for you to have a look at this, and you can find this in the photo gallery at the Pace Turf website. That's one part of the website that's open to everybody. You don't have to be a member at Pace Turf to see this chart, although I would appreciate it if you do find this stuff interesting. I think you would find it even more interesting to be a Pace Turf member and get full access to everything on the site, including some analyses of the Delta GP for the past 5 years at your location, which is something that you get with a membership. Anyway, the chart that I'm showing, on the horizontal x-axis, it shows the percentage of the days in the summer with a negative Delta GP, meaning it's showing the percentage of the days in the summer when it was better for warm season grass than it was for cool season grass. Again, if you're growing warm season grass, if you're in Naples, Florida, or if you're in Miami, or if you're in Bangkok or Singapore, this isn't really the way that you would look at the stressfulness of the summer, because in places where you're trying to grow warm season grass, you really want it to be as hot as possible, and you're concerned more with the combination of temperature and light and temperature and precipitation. So that's a different analysis, one that I've made some before, and I intend to update that, but that's not what this is about. This is more about the places like Shanghai or Tokyo or Washington, D.C. or Atlanta, Georgia, where you might be growing bent grass on greens, but in the summer it's so hot that it's really better conditions for warm season grass, at least for temperature. So let me give you an example. On this chart, it shows for Atlanta, Georgia, in the summer of 2024, the Delta GP was negative on about 70% of the days. So the temperature was so hot that on 70% of the summer days, it was better for warm season grass than it was for cool season grass. And now let's look at a place like Sapporo on Japan's northern island of Hokkaido. Sapporo was less than 25%. I'm going to say that that's at about 20%. So 80% of the days last summer in Sapporo were better for cool season grass. 20% of the days were better for warm season grass. Chicago is at about 37 or so, 35%, something like that. New York is at about 37%. Perth, Australia. I thought Perth was a little bit hotter, and Perth does have some extremely high temperatures in Western Australia, but it also cools down some in between those hot stretches, or at least it did in the summer of December 2023 going into March of 2024. So Perth is still less than 50% of the days. So I looked this up for a lot of places where there are a number of golf courses: Cape Town, Johannesburg, Sydney, Denver, Niigata, Rome, Augusta, Tokyo, London. In London, the average temperature last summer was 18 degrees Celsius. That's about 64 degrees Fahrenheit. And there were 0 days in this assessment. There were 0 days in London where the temperature was more suitable for warm season grass than it was for cool season grass. So this is just isolating the effect of temperature. This is something that I think it's interesting to do, to look at different locations around the world and to look at the same location over multiple years. So you could look at like a 30-year time series of summers and check what you find in terms of the intensity of the summer. Let's see. I'll change the display just a little bit. All right. For those of you watching, you'll see a slightly different display. I'm going to transition now to talk about the different ways of considering what the summer is. I have, in the past, been looking at these transition zone places, or the places like Shanghai where it gets really hot in the summer, or places like Atlanta where it gets really hot in the summer, and tried to express how difficult it is, how challenging it is in a particular summer to manage cool season grass. And to do that, I've expressed the summer length as the duration of time from the first day in the year when the delta GP is negative to the final day in the year when the delta GP is negative. So that is not based on the calendar at all. It's just based on the weather. And there's some advantages and disadvantages to looking at the summer duration in that way. One of the advantages is for places that have a really long summer, like 6 months long, really high temperatures, then that is going to capture that because it's based on the weather. It's not based on the calendar. So that's the advantage. But the problem is everywhere in the world has summer, but not everywhere has summers where the warm season growth potential ever exceeds the cool season growth potential. The average temperature sometimes never gets hot enough for you to have that negative GP. So I've done this in the past, and I included San Francisco, and I used Wellington, New Zealand, Auckland, New Zealand, places like London, and I want to compare those for reference. How do they compare to New York City? How do they compare to Atlanta or Augusta or Los Angeles? And the problem that you run into is, according to that definition of summer, those places don't have summer, which is completely incorrect. That's not the correct assessment. It's just that it doesn't get so hot there. And because it doesn't get so hot in some places, we can't use the negative delta GP as a criterion for the start and the end of summer for the entire world. So that's one negative to it. And I think that works really good when I'm isolating, for example, the summer intensity in Japan. In Japan, pretty much anywhere in the country, it does get that hot in the summer. It gets hot enough that you will have days where the delta GP is negative. So in a place like Japan, where everywhere gets that hot, you can focus in on that kind of analysis and check from the first day in the year with a negative delta GP to the last day in the year with a negative delta GP and say, for this year, that was the duration of summer. And then you can make various calculations about the temperatures or the weather conditions that happened from that first day to the last day. I've mentioned one of the negatives to that assessment being in places where it doesn't get that hot, like Wellington in New Zealand or London in England, then we can't get a start and end of summer date using that particular analysis. So it doesn't work all over the world. That's one drawback. A second drawback is we have to wait we have to wait well into the autumn. Whether we're in the northern hemisphere or in the southern hemisphere, we have to go well into the autumn to make sure there's no more hot stretches. So we can't, like, right at the end of summer, we don't know when summer has ended until it has ended. So we have to wait and wait almost into the winter. And then we can say, okay, now we're ready in winter to make our analysis of the summer. But if we're curious about the summer that has just passed, we might want to do an analysis sooner. So it's kind of nice to have a fixed starting date for summer and a fixed ending date for summer if we're going to be doing some type of analysis. So that is another drawback of the letting the weather tell us when summer was. So then there's two conventional ways. I looked this up on Wikipedia. The standard meteorological summer dates for many parts of the world are in the northern hemisphere, June, July, August. From the start of June to the end of August, that's summer. In the southern hemisphere, it's often December 1st to the end of February. It's December, January, February. That is summer. That's the meteorological assessment, or the meteorological duration of summer. And then there's the astronomical duration of summer, which in the United States, or certainly the type of schools that I went to growing up, we were often taught that summer starts on about June 21st or June 22nd, which is the summer solstice, or the longest day in the year. And that would be the first day of summer. And then the last day of summer was on the autumnal equinox. And that is usually about September 21st or so in the northern hemisphere. So in the southern hemisphere, that would be something like December 21st to March 21st, something like that. But in some places, it's getting cool already going into the time around the autumnal equinox. And in other parts of the world, it starts getting hot before the summer solstice. And in fact, I looked this up for many places, as shown on that chart that's in the blog post that is from Pace Turf. And actually in Atlanta, the 7-day period in 2024, the 7 consecutive days with the highest temperature, they started prior to the summer solstice in 2024. So if we would have used June 21st as the starting date of summer, we would have missed some of the hottest weather of the year, which that doesn't make sense. So what I've done is said, let's combine the meteorological and the astronomical summer boundaries and make that as wide as possible. So we'll start at the first day of meteorological summer and we'll end at the last day of astronomical summer. And doing that gives us a southern hemisphere summer that goes from December 1st to March 21st. And in this case, it was March 22nd of 2024. So looking at the 113 days from December 1, 2023 through to the 22nd of March, 2024. And in the Northern Hemisphere, I went from the 1st of June through to the 21st of September. So that gives 113 days in the Southern Hemisphere and 113 days in the Northern Hemisphere that make a nice summer that we can then come right to the end of it and we can say, okay, now by that definition, summer is over. We can check the temperatures, find out what kind of a summer we had, and we don't have to wait for some potential hot spells in October. or some potential hot spells in November. If we were in a place like Hong Kong, for example, it would be so warm going into November that we would still have some days in a typical year with the delta GP being negative. And we can look at how this displays. I showed a couple charts in the blog post where it shows the daily delta GP. The first one is for Portland, Oregon, and it never really drops below zero. It's never negative. It dips in late July of 2022. I'm showing a chart from 2022. There's a big dip in the summer where it drops down to around zero, but it always stays positive because in Portland, Oregon, it's rare that your average temperature will ever be above 24.8 degrees, which is what it needs to be to have a negative delta GP. And then the next chart I showed is for Hong Kong in 2023. And in Hong Kong in 2023, the delta GP went negative in May, and it almost went negative in a hot spell in mid-April, but it went negative below zero starting in May, and it did not rise above zero until the middle of November. That was in 2023. So this is a way that is complicated the first time you hear it and you say, what is this all about? Do we really need to make it this complicated? But then it turns out to be kind of an elegant way to express things like a summer length or the intensity of the summer, or just in very plain terms, how difficult it was for cool season grass to grow, given that the temperatures were so much better for warm season grass. And in some of the places on this chart, such as Shanghai or Dallas, Texas had about 80% of the days in that 113-day period that combines the meteorological and the astronomical summer. It had about 80% of the days in the summer of 2024 that were better for warm season grass than for cool season grass. And Miami was 100%. In Miami, the average temperature was actually a little bit higher in Dallas in the summer of 2024, but I included Miami on this chart because Miami for me is pretty much a clear warm season area. I included Naha in Okinawa, Japan. Naha for me is also pretty much a purely warm season area. And both Naha and Miami had an average temperature of about 29 degrees Celsius for that 113-day summer period, which is about 84, a little bit above 84 degrees Fahrenheit, I think. And 3 places were warmer than that, if I'm reading the chart correctly. Shanghai, where people do manage bentgrass greens. Athens, Greece, where I am not sure what species is grown in Athens, actually. I expect that cool season grasses may be used on the greens in Athens. And Dallas, Texas, where you could have both cool or warm season grasses on the greens. So there are a number of challenging places around the world to grow grass. And I'm not saying that anywhere is easy. I'm not saying that anywhere is the most difficult, but you can find various types of weather data that can help to support the work that you're doing and support the resources that you need and support the types of challenges that you are very likely dealing with no matter where in the world you are growing grass. So that is what I wanted to discuss today. It's that blog post that I will put a direct link to in the show notes about the delta GP. If you haven't looked at delta GP before, you might find it useful if you're anywhere in the world that has a type of summer condition where the average temperature ever gets above 24.8 degrees. And that's going to give you the negative delta GP. And when if you're in Reykjavik, Iceland, I don't know that it's useful to look at this because you're always going to have a cool season GP that's higher than a warm season GP. But for places that it gets a bit warmer than that, get down into Paris or Madrid and Prague and Berlin, and you can have temperatures that are warm enough that you can have days that are better for warm season grass than they are for cool season grass. It can be interesting to look at that to help to understand just how challenging any particular year was. Well, thank you so much for listening. Thanks for your interest in these topics, and you will certainly find more information at my website, asianturfgrass.com. For now, I will sign off and promise to be back again before too long with more interesting turfgrass information. For ATC from Trong, Thailand, I'm Michael Woods. Bye-bye.